In this lesson, we'll implement the Remember Me option on the login page. We'll do this by manually setting cookies on the user's browser without using the session. I am currently logged in. Let me close the browser and open it up again. If I try to access the site again, you can see that I am logged out. Session cookie will only exist until you close the browser, which is useful, but some users may want to be remembered so that they don't have to log in every time they open the browser again. So here is the plan. Let's say that each user has an additional column in the database called Remember Hash. If the user checks off the Remember Me checkbox, we will generate a random token. This token will be sent to the user's browser inside of the Remember Token cookie. We'll create a hash of that same token and save it in the Remember Hash column of the logged in user. Even if somehow someone gets the access to the database, they won't be able to get the Remember token because it is hashed just like the password. We will also send another cookie which will contain the user's ID. Don't confuse this user ID cookie with the user ID we set in the session cookie. The user ID from the session is just a part of the session dictionary, and this new user ID is a separate cookie which we will create manually. These cookies need to be more permanent, which means that their expiration time should be longer. In this application, I will set it to 100 days. When the user opens up the browser again, the cookies will still be there. They will also be sent with every request to the application. We can then inspect them and take out the user ID first. Once we find the correct user, we need to check if the Remember token from the cookie will give the same hash as the Remember hash from the user in the database. If it does, that means that this is the correct user and we can log him in again. This Remember token is random so that no one can guess it, only the right user will have it saved inside of the browser. This approach has one problem. What if the user logs in on two browsers and wants to be remembered on both of them? The first browser will send the token and save the hash to the database. The second browser will create another token and overwrite the hash from the database with the new hash from the second token. Only the second browser will remember the user. The first one has an old token which no longer corresponds to the hash in the database. This is why instead of a simple column, we need to create a separate model just for storing these Remember hashes. We can call this model Remember. This table will only have two columns, user ID and the Remember hash. User has a one-to-many relationship with this Remember model, which means that the user can have more than one Remember hash, which eliminates the problem with the more browsers. Now that we know the theory, let's implement that in practice. I will first implement some general function for creating random tokens. The secrets package has a token URL safe method to create a secure random token. Generate token function will simply use this method to create a token. I will limit the token size to 20 bytes. Generate hash function will take in some token and hash it with the Factoid's generate password hash method. Check token method will check if the given token corresponds to the given hash. I added the underscore as a prefix because we'll soon create another function with the same name, and this one will just act as a general helper. Now let's define the Remember model. This table name could be Remembers. This model will have three properties: an ID, Remember hash, and the user ID. User ID is a foreign key to the ID column from the users table. The init function will only take the user's ID. We'll first generate a token with the generate token function. Then we'll hash that token and save it inside of the Remember hash column. The user ID will of course be the past ID from the parameter. Notice that the generated token is saved inside of this temporary token property. This token won't be saved to the database, but it doesn't need to, we only need it for a short amount of time anyway. Finally, let's define the check token function, which will make use of the check token helper function we defined before. Pass the Remember hash and the token from the parameter. Now we can define the other side of the relationship inside of the user model. The user will see this relationship as his own Remember hashes. Notice that I added the delete orphan cascade option. If the user ever gets deleted, all of the Remember hashes that belong to him will be removed too. This Remembers table doesn't exist yet in the database, so let's add it with the Alembic migrations. I will create a new migration called Adding Remember Hashes. Now we can upgrade the database. Okay, now that we got the model set up, let's get to the front end. I will add the Remember Me checkbox to the login form. This will be defined as a Boolean field. Don't forget to render this field inside of the login template. I will put it after the password field. Now let's go to the login view. After the user is logged in, we will check if the Remember Me checkbox is checked off. If it is, we will make a new response to the main home page. To create a response, I need to import the makeResponse method from Flask. So why did I create the response like this? Why not just return the redirect directly like we did here? That is because we need to send cookies to the browser, and the only way to do this in Flask is to attach it to the cookies header of the response. Before we do that, let's first create the Remember token. Of course, this method doesn't exist yet, so let's implement it inside of the user model. This function will create a new Remember instance with the user ID of the past user. Then we can add this instance to the database session and return the nHash token. This token is the temporary property we defined in the Remember model. It will only exist until this instance gets deleted, but we only need it until we store it inside of the cookie. After we get the Remember token, I will commit the database session to save the Remember hash to the database. Now we can add the cookies to the response with the setCookie method. The first argument is the name of the cookies. The second one is the value we want to pass in. In this case, these are the Remember token and the ID of the logged in user. MaxAge parameter will determine how long will cookie exist in the browser. It is defined in seconds, so I will multiply it by 60, 24 and 100 to get the amount of seconds for the duration of 100 days. It is a good practice to encrypt the data inside of the cookie. Flask does that automatically for the session cookie, but we need to implement our own encryption for setting them manually. I will import the URL safe serializer from the It's Dangerous package. Flask uses the same package to sign the session cookies. Let's create two methods, encrypt cookie and decrypt cookie. First we need to initialize the serializer. The first argument will be the secret key from the application configuration. To fetch this config key, I will use the current app variable. We need to import this variable from Flask. We use this because we cannot access the app instance from the authentication blueprint. The second argument is optional, but I will add it just to make the cookie content a little bit more confusing for the potential attackers. Now we can use the dumps function to encrypt the content and return the encrypted content. The decrypt cookie method will do the reverse. We'll define the serializer in the same way, but now we need to decrypt the encrypted content with the loads method. If someone tampered with the cookie content, the serializer will throw an error, so let's catch that error, and if it happens, set the content to some random value, like for example -1. Now we can use the encrypt cookie function to encrypt the content before sending it with the response. Finally, return the response to the user. Let's see if this will work. I'll log in with the Remember Me checkbox. If you take a look at the cookie storage, you will see that our two new cookies are saved in the browser. Great! Now that we know that it works, let's use them to log in user after the browser gets reopened again. We'll add this functionality to the getCurrentUser function. I will break this condition and put the first part up here. If the current user is null, check the session for the user ID. Now we need to add another condition here. If the session is not set, then check if there are any cookies with the name user ID. Just like the session, these cookies get sent from the user's browser on each consecutive request. We need to import the request object from the Flask package, and by doing this we have used all of the context globals mentioned in the previous lesson. You set the cookies on the response and get the cookies from the request. So if there is a user ID cookie, find the user from the given user ID. Don't forget to wrap this with the decrypt cookie function because the cookie is encrypted. Also, we need to cast this cookie value to integer. This is why I chose -1 as the default cookie content. If someone tampered with the cookie, this will return -1 and the integer casting will not throw an error, but no user will be found with that ID. Let's implement this method in the user model. This method will only take one argument, the token it needs to test out. If there is a token, we will loop through all of the remember hashes that user has inside of the remembers table. If either one of these hashes corresponds to the given token, this method will return true. Otherwise, return false. To check the token, we can use the remember model's checkToken method. Back in our current user function, we check if both of these conditions are met. If they are, that means that these two cookies were not corrupted and that the user has a correct token. In that case, we will log in user and set the current user variable to the user from the database, just like we did before. So if the session doesn't exist, the cookies will be checked next. And now for the moment of truth. Let's close the browser and open it up again. And we are still logged in. Notice that the session cookie is also there because we used the login user function. We are finally done with the Remember Me functionality. We only have one more thing to cover in this module, so if you are still here, congratulations. And also, thanks for watching.